Hello, so today we are going to do Leetcode day 26, I think, or 27, maximal square. And the problem says, given a 2D binary matrix filled with zeros and ones, we want to find the largest square containing only ones and return the area. So the largest square, that's what we're looking for. So here, for example, the largest one is this one. This is a square of containing 4 ones, right? Its area is 4, which is basically the number of ones in it. Notice that we didn't take this because it should be a square, so we want the largest square. So couple of things here I think worth mentioning. Largest square, kind of maybe dynamic programming, and then we have square. What is a square? What are the properties? Is that just the size, right? You just need the size. So you need the size and you need the start position. So you need ij, which is start position. So pretty much all we need to know is where are we starting from and the size to know, to be able to know how many are there, right? And we can't extend here unless we can extend here, right? So that's another property. One thing we can think of is, okay, let's just do brute force, which would be just go through all of them and find the, so go through the entire square and find the squares that have this property, right? So so that would be, so we would go through, so from 0 to, so this is the rows, right? 2 rows, and then we'll do j, and we will consider this to be the starting point, right? And then maybe for size from 1 to, so the size is the max, so say max size, which can be the max of number of rows and number of columns, right? So we could just say to max size here, and then after that we could check if all ones, right? So if all ones on that square, of course, then we should do something like take the, what is the size, what would be the number of ones, what would be the area, right? So it would be, I think, size square, right? To the power multiplied by size, right? Because area of a square okay, so it's just like, let's say 3, it's 9. For, yeah, so you get the idea. It's it should be, we could just say, since we want the largest one, right? So we could say best, right? Start out from 0 and just compare this with max best so far, right? So this would be a good brute force solution, right? But my guess is it will probably, it's not the best solution, so how can we improve on this one? I'm thinking, can we use prefix sums in some way? So if we do prefix sums, what will happen is that we would have some positions that have, let's say, 4, right? So we'd have this position here be 4, right? So we'd have 4 here. Would that help us in any way? Actually, it won't be 4 because it's the entire thing. So, but we can like know the square area pretty fast, right? And we know the size, right? So we can know that it's all ones. So with prefix sums, we can calculate this sum pretty quickly. And by just doing some subtractions, right? And then if we know the best, so if we know the size, basically I'm trying to make this optimal because otherwise we would have to go through the entire square. And so if we know that this is equal to this, then by doing just prefix sum calculations, then we will be able to, in O of 1, so in O of 1 time, we will be able to tell this part here, right? And so that leaves us with O of, if rows were n and columns were m, it will leave us with, this would be min here, this should be min, min mn, which would be better than what we had with the brute force, which was O of m n multiplied by m multiplied by the min here, right? Multiplied by, of course, there will be here calculations of the prefix sums, but that won't be too much. And then we would have, for all checking all the ones, that would be also the size, right? Because we would have to check every one of them. Yeah, so something like this. So maybe this square, I think, kind of. You could abbreviate it to kind of O(n) squared if O(n) cubed, because if this was the same size, n, if the number of rows were the same as the number of columns, you'd get n multiplied by n multiplied by n squared. So actually to the power of 4. Okay, so with this prefix sum here, so this prefix sum idea is a good idea. I think we could solve it that way because we wouldn't need to do this check, right? But I think actually it would be simpler to do this dynamic programming and easier to do this initial DP solution. Okay, let's try that one. So we will need a DP array. So our ij, what would be that state? So for me, that state would be the, let's say it's the square ending at position ij, right? As I said, the state is the size and ij, right? And so the size will put the size in the array itself, right? And so what we would have here is that we would have dp of ij equal to, so if we have, let's say a square like this, where we have 1, 2, 1, right? So what is the value here? So having 2 here means that 2 here, for some reason, it was the ending of the previous square, right? But we can't include, we can't put 2 plus 1 and make 3 because here is just 1, which means that there is 0 maybe above it or to the left or something, right? So which means we need to take the min and extend by 1. And the min is 1, so we'd have 2 here, right? So what this would mean is it's the min of all these neighbors plus 1. So it's the min of I minus j. But this we should do it only if the matrix at position ij is equal to 1. Otherwise we it's 0. So whenever we encounter 0, the square ending at that position has size 0. So this is size, by the way. And so we would have I minus 1j, dp of I j minus 1, and then dp of I minus 1, j minus 1. And plus 1 because we are extending it, right? So, and then that's pretty much it. At the end, we'll just keep track of doing max length here, which would be equal to max of max length and dpij. And then at the end, we could just return max length squared, right? So this should be, let's first have the size of zeros in columns. So that would be columns equal to length of matrix and length of matrix at position 1. Sorry, matrix 0, the first row. One thing we should do here, if not matrix, return 0. So this would be range of rows, and so this would be range of columns, and then we could do this for okay. And now we could go and fill our DP array. So we go for all the rows and then for all the columns. And then we check if matrix we just do this actually. So max length, let's initialize it, starts out as 0. And then at the end, we should return multiplied by max length, right? There is just one caveat here, which is I minus 1 for 0, we would get minus 1, which is the last element of the array, which is not what we want here. So we need to check for equal to 0. So at this point, we should for these values in the boundaries, if it's 0, then the size is 0, and the size of the square ending at 0, because there's only that element. If it's 1, then the size of that square ending at 1 is 1, right? Because there's only that single one value or element, right? So what this would mean is that here, if this is equal, then we could just say max, or actually fill dp. So dpij is equal to 1 if, and we could do this after. So this is if this, else we could say 0. We could also just say equal to this. That will also work, but let's just do this this way to be clear. And so let's run this. J here. Okay, looks good. Let's submit. Okay, so that's accepted. One slight modification that I can make here is simplify this condition. So by making this end at j minus 1, I minus 1, j minus 1, just changing my state. So what that would mean is that I could make this until columns plus 1, rows plus 1, and make this start at 1, rows plus 1, just to avoid having to deal with 0. And then that way we could just have this, and that's pretty much it, right? Yep, let's try. Yep, so this would be I minus 1 also for us to get the right value. Because yeah, rows plus 1, it will give you rows, and that's not a valid index. Okay, so that works too, and it simplifies it a bit. And for both the the time complexity is just O of m. N is the number of rows, m is the number of columns. So it should be pretty fast, right? So it's O of n squared if the sizes were the same. Yeah, I think this is it for this problem.